before you try to use it on the quiz, just to make sure you know how to draw the arrows in. Because remember what I told you. If you draw the arrows wrong, everything is wrong. Is there any partial credit on the quiz? No.
So it should be 1, 1, 2, 2, 3, 3, 4, 3, 2, 1. How many are in each one?
Yeah, you're right.
1, 1, 2, 2, 3, 4, 3, 2, 1.
Yes.
Yeah, okay. I'm sorry.
What is she talking about? All right. So let's write an electron configuration. An electron configuration compared to an orbital notation is the easiest thing that we will do today. Okay? Simply because they are much shorter. If you remember what I told you yesterday, an orbital notation is the longest because an orbital notation shows every single electron in every single orbital. So it takes the most time. An electron configuration is different because it only shows total electrons in the sublevel. Okay? So it's going to look like 1s2, 2s2, 2p6, and so forth and so on. Okay? Do you see any arrows in that? No. Okay? So there are no arrows in an electron configuration. When we take our quiz on this, whether it be Monday or Tuesday, and we'll figure that out based on how far we get today, will I tell you which one is which on the quiz? No. So you have to know that this is the one that does not have the arrows. Okay?
What is that? 2s2?
2s2.
So we know that it doesn't have the arrows.
Huh? Because I'm telling you that today.
But why the arrows?
The orbital notation is the one that had the arrows, right? You drew the lines, had all the arrows that you did for homework last night. That's called orbital notation. You have to know that on the quiz. This one that we're learning now is called an electron configuration. Clearly the one we're doing next, it's called a dot diagram, has dots in it. That one usually people don't get wrong. Okay, but these two they get backwards.
So the question would be like,
it's going to say, I'll even tell you what the quiz has.
okay.
It's going to say, draw two orbital notations, draw two electron configurations, draw two dot diagrams, draw two shorthands. Okay? There's 8 questions. It's 2, 2, 2, and 2.
When is this quiz?
Either Monday or Tuesday. If we get all the way through shorthand, it'll be Monday. If we don't, it'll be Tuesday. All right. So if we look at how to write one, let's just start easy. Okay? Let's say we're going to do one for magnesium. No, let's do aluminum. Okay? Aluminum has how many electrons? 13. All right? 13 electrons. We read the first thing in the chart. What's the first thing in the chart up here?
1s.
Okay. 1s. How many electrons total can an S sublevel hold?
2.
Then we simply put a 2 right here. Now, 2 electrons. Does that equal to 13?
No.
Then we go back to the chart. What's the next thing in the chart?
2s.
How many electrons can an S hold?
2.
2 plus 2 totals what?
4.
2 plus 2 is 4. Is that 13 electrons?
No.
Back to the chart. What's next in the chart?
2p.
2p can hold how many?
3. 6.
Remember, we're not doing the lines. We're doing the total electrons this time. So p can hold 6 electrons, right? So 2 plus 2 is, plus 6 is 10, 13 electrons?
No.
Back to the chart. What comes next after 2p? 3s. 3s can hold how many?
2.
So 10 plus 2 more is 12. We're almost at 13. We're just not quite there yet. All right, what comes next? 3p. Now, we all know a p can hold how many? 6. But 12 plus 6 puts us at what? 18. We don't want 18. We only want 13. So we're going to put 3p what? 3p1. That is an electron configuration.
Oh, I don't like that.
I like
Told
this
you.
one better than the other one.
I told you, orbital notations are the longest, and people dislike them the most. All right, everybody got it?
Yeah.
Can I erase?
Yeah.
Because I'm sure I can't paste this chart any better today. Once they change this computer, it doesn't like me. But it works better than the other. All right, let's say we do a longer one. Let's do, yes, let's. Let's do, I don't know, let's do selenium.
I knew you were going. I looked at.
All right, how many electrons does selenium have?
34.
All right. So, what's the first thing in the chart? How many electrons can it hold? All right, what's next? How many can it hold? All right, what's next? How many can it hold? Next? How many can it hold? All right, next? How many can it hold? All right, before we get crazy, let's count. Where are we at? 2 plus 2 is, plus 6 is, plus 2 is, plus 6 is. Not there. Let's keep going. What's after 3p? 4s can hold. Next? Can hold. 3d can hold 10. Now, 4s2 is 20. So 20 plus, we're at 30. So we're almost there. So after 3d is what? 4p. Now if we're at 30, 4p only needs how many? Only needs 4. Questions?
No.
You got it?
Yeah, sure.
Fabulous. Now, don't do like you did yesterday and just start copying from your electron configurations and make dumb errors. Use the chart to do it. Now, let's do potassium. Let's do phosphorus. And let's do antimony.
Come on.
What I said.
Yeah, by yourself.
What is this? 15.
Come in. That nigga, the P, the S hold 2, the D hold 6. Oh yeah, D hold 10, and F hold 12.
14. Remember your quantum numbers we were working on before you went to JROTC? The same numbers we were learning? That's where these numbers come from. All right, who are we missing today while y'all are doing that? We'll do the attendance. I know Abraham, because he told me he'd be out yesterday today. We missed anybody besides Abraham? No. Nope, just Abraham. All right, we done? All right, Liz, you are be patient for a second. Hey.
Yeah.
Hey, some wine. Hey, some wine. What? Hey. What are you doing? Come up on.
Oh, shit.
We're already like today. Behind class, and we've lost 2 days. Technically, like 3 days.
But I'm right on the physical science. We need to be. Yeah.
Yeah, no, technically.
I get it.
So I put out models for CCC. I'm sure she did one with no honor. We did models last year today. They did models together.
Oh, much. All right, so for K, what'd you write down? 1S, 2, 2S, 2, 2P, 6, 3S, 2, 3P, 6, 4S, 1. Everybody got it?
Yeah, sure.
All right, P, 1S, 2,
2S, 2, 2B6, 3S, 2, 3B3.
yes. All right, and SB.
1S2, 2S2, 2B6, 3S2, 3B6, 4S2, 3D10, 4B6, 5S2, 4D10, and 5B3.
I was a little weak on that last one, but it should end on 5P3. Questions? Do we need to do any of those?
No.
Everybody's got
How would it end on 5P30?
it. Okay?
Oh, no.
Yes. Because if we can't do these, we cannot do dot diagrams. You have to be able to do orbitals and electrons to do dot diagrams. Okay. All right. Dot diagrams are different. Okay? Because dot diagrams only show outer shell electrons. Now, outer shell electrons are also called valence electrons. And you will hear me use these words interchangeably. And I have a really bad habit. I call them outer shell electrons when I teach the periodic table, and I call them valence electrons when I teach bonding. I have absolutely no idea why I do it this way. I just always have. But they are the same thing. So while I'm teaching the periodic table, you are more likely to hear me call them outer shell electrons. And when I teach bonding, you are more likely to hear me call them valence electrons, even though they are the exact same thing. Okay? Now, if dot diagrams only show outer shell electrons, we have to know what the difference is between an outer shell electron and an inner shell electron. So, what on earth is an outer shell electron?
The electrons on the last ring.
Okay, that's not a bad answer. They're an electron on the...
Last ring of,
Okay, I'm going to use a word that you're likely to see on a test. An electron on the highest main energy level. Now, I will put in parentheses here the last ring because that's not necessarily the wrong answer. Okay? But it's the highest main energy level. So, Highest main energy level. Now, the definition for the inner shell, you're going to love this one. Yeah. Anything that's not the outer shell is the inner shell. Because the outer shell is one energy level. The inner shell could be one ring, could be two rings, could be three rings, could be four rings, could be any number of rings. It just depends on the atom you're looking at. Okay? Could be what? It could not, because remember, the principal quantum number n is really going to be limited for us to 1 to 7. So it could not be 4 million rings because we're not going to have that many rings in and out. I mean,
What
it's
would
just
that
not.
mean?
Huh?
What would that mean if something happened?
The atom would be gigantic, I would imagine. The atom's just
Like
obvious.
this big?
I have no idea. All right, is everyone caught up? All right, so the biggest challenge we have today is just learning how to identify an inner shell from an outer shell. Okay? So I'm going to write a couple. Did you give me a go back? And when you have it, Celia. Okay? All right, so let's say that we have, I'm going to just write a couple. I'm not going to write a bunch. So let's say we have aluminum. And let's have gallium. And all right. Can I give you a minute to write that down? So I know some of you are. And we're going to draw these dot diagrams.
I think we leave space in between each one.
You might want a little bit. I don't think it needs to be a ton of space. Now you could do it down below too. I don't think if you didn't leave any, it's a big issue. I mean, I certainly wouldn't erase and get bent out of shape.
Okay.
Okay.
Right. All right, we got it written? All right, so if we look at aluminum, okay? Aluminum is a pretty typical electron configuration. I gave you lead simply because we're going to do lead in shorthand. We're not going to write that one longhand again after we've done it this time. All right, when you look at aluminum, how do we
decide the highest main energy level? How do we decide that? Okay, if I go back to that wording, energy level, how do we decide the energy levels?
The letter, sub-level.
Okay, the letters tell the sublevels, right? The numbers, okay? So when we look at the numbers, what's the highest energy? I'm going to write that up here. That way you can label your notes. Because like I told third period yesterday, we're not going to test again this quarter because grades have to be turned in. I don't think they have to be posted, but they have to be finalized and finished in terms of being entered in the computer before we all go home 12:30 on Thursday next week. So we won't test before Easter break. What does that mean about where our test falls? After break. So all this stuff we're doing, all those quantum numbers, all those weird numbers, all that stuff, you got to keep all that in your brains until when? After break. So if you don't think you'll remember this stuff after break, make a note to yourself. So when you, because I'm hoping you'll study. This will be your first test on the new quarter when we come back. Okay, that's the downside to not doing this before break. Okay, so the highest energy level is, of course, the number or the coefficient. So, which one is the greatest coefficient for aluminum? The 3. Not the S or the P, but the 3. So how many 3s do we have? 2. So all of this is the outer shell. That means everything else that's left is the what? All of that is the inner shell. That's why I said in the definition, anything that's not the outer shell is the inner shell. In this case, it's only a first ring and a second ring. But if you look at like gallium, here, where's the outer shell?
Right.
4.
Here we have a 4. Notice that this time, what can you tell me about the 4? So they side by side. They're separated by the D this time, right? Because we've got some overlap going on. So this time, the D is there. Okay? This is the outer. And then this. And then all of this is my inner shell. Now, it gets even worse with lead. With lead, what's my outer shell? The 6. And you can really see some overlap here because you got a 6 here and you got a 6 over here. Those two are part of the outer shell. And then all of this in here and all of this is inner shell. Okay, so there, rings 1 to 5 are inner shell. Okay, that's why I couldn't say just rings something to something was the inner shell in the definition. Does that make sense?
Yeah.
Okay, any questions about how to find inner and outer? Now, to draw the dots, okay? First of all, everybody got what they need off this? First of all, you're always going to draw the symbol, okay? And in your head, I want you to envision a box, okay? On the side of each box, you can draw a max of 2 dots, okay? So, if there's a max of 2 dots on each side, how many total electrons can there be in a dot diagram if there's a maximum of 2 dots on each side? 8, okay? So the maximum number of dots we can have is 8. Secondly, the symbol is going to represent all inner shell electrons and the nucleus. Okay, so that's covered when we do the symbol. So, this is what cracks me up when I ask for a dot diagram.
So if I draw, for example, gallium, which has 31 electrons, and people draw something like this for me, which I actually get on the test. How many electrons did y'all just tell me gallium could have? Maximum. If you don't know the answer, you need to guess something between 1 and what? Don't draw me rings around an element. Okay? You can't have more than 8. So guess something between 1 and 8. Okay? Everybody good on that? Don't do that stupid stuff.
Hello.
Don't draw rings. Yeah, butterflies would be good. All right, so let's say that we're going to draw aluminum. Now, here's the part that people struggle with. You have to draw the dots to look like the electrons. This is why you have to know how to draw orbital notation. Now, we don't have to draw this whole thing in orbital notation. We only have to draw the outer shell in orbital notation. So, what does the 3s and the 3p look like in orbital notation? 3s has how many lines above it?
1.
3p has how many lines above it? Okay? How many arrows does S have?
2.
How many arrows does P have? Now, when we draw the dots for aluminum, these dots have to mimic the arrows. Okay? Envision 4 sides on aluminum. We don't actually draw the box. So, I have 2 arrows that are paired, right? I draw 2 dots that are paired on one of the 4 sides. It does not matter what side you choose. I tend to start at the top. You do not have to. So there are 2 dots to represent the 2 arrows. I have a single arrow, which means I need a single dot. I have 2 empty orbitals, which means I need 2 empty sides. Questions? Okay. Huh? There will never be more than 8. Ever. Okay? Now, what can you tell me about GA without us even drawing it?
Same thing.
It will be the same thing. All right, so let's draw lead. All right, 6S has how many lines? 6P has how many lines? 3, right? How many arrows are in 6S? 6P has how many arrows? How do I draw the 2 arrows? Together or separate? Separate. Remember, one goes in one room, the other one takes his own room. They're not going to share unless I have to. All right, so when I draw lead's dots, these 2 arrows are doing what? So are they together or are they separate? So I'll draw 2 dots that are what? Together. This time I'm going to draw them on the side just to show you they can be anywhere. Okay? These 2 arrows are what? So I'm going to draw 2 dots that are what? Okay?
So it doesn't matter which side you start on.
Nope. So that time I split them up so that one's on top, one's on the bottom. Okay? And then I have an empty orbital, so I should have an empty what? An empty side.
So as long as we got the dots in there, it doesn't matter where they're.
That is correct. Yes, Andy.
What if there's a 7 after 14?
You will not have what 2 sublevels is an outer shell. But 2 sublevels will never be an outer shell. F and D. Because you cannot have more than how many electrons in the outer shell? 8. So D and F will not be an outer shell. If you get D or F as an outer shell, you have a what? That is correct. Okay? All right. Do you have your homework from last night? All right. You should also have some from yesterday. We should have chlorine. We should have what? MO. We should have GE.
Should have AU. Yesterday we drew what? Give me something we drew yesterday. PO. TI. Give me one more. SN. All right. Find those in your notes. You got 4 for homework, and we drew 3 yesterday. Draw. I want things we've already done. I don't want to spend all day drawing things we've already done. Okay? Draw their dot diagrams. You should already have the work. Okay? So it should be fast to be able to draw their dot diagrams. You just have to locate their work in your notes. Okay? And draw their dot diagrams. Okay, you got fun. Why are you rolling your eyes and getting mad at me? First cheating, making Miss Worley mad, now you're on your phone making Miss Wall mad. Do you work?
What did you just say? What did you just say?
I said, first you're eating Miss Worley's class, making her mad, now you're on your phone making me mad. Do you work?
Stop.
Please.
No, please. Come on, stop. Do you work?
Are you?
You're not in band class. Those are not drumsticks.
No help.
You had an opportunity outside of class to catch up, so you knew how. I told you what to do yesterday when you came by to find out what you missed, and your response was, no, thank you. So now don't be a pest. The rest of you can find your answers. Just sit there, but don't beat on the desk. Yeah. Yes, no, yes, yes. Where's what's your outer shoulder? Mhm. No. How many 4s do you have? Oh. Yes. That was good. How many lines of P? You got that P, you got any other 6s?
Oh, no.
That's why I picked that one. A lot of people miss both parts. Yes. Yeah. First form. Yes. Oh, you got some of those. Those ones we did. Those 3 or 4. You else has got stuff. Where are you confused? Oh, okay. Question? What you got?
I don't know what to do.
You got the right number document in one place. Yeah, well, it don't have to be on a certain side. They just, you got 2 pairs. It should look like lid. Yeah, you got lid going right there. It should look the same way. So when you see your configuration, yeah, see how those are paired right there? They should be separate. They should have their own on each.
Well, I'm glad we're not gonna have to shed any tears today, because they're correct. I bet you. Yes. How many dots is that? Alright. No, because you got 2 here, you got how many here? So you should only have 4. Don't matter. Pio's right. No, hold on. Yo, got 6S. Then. Hold on. Yeah. Tell me this flat wrong. So, mark that one out. That was just not right. The whole configuration's wrong. We gotta go back and recount. So, I'll say. Minus 3D, 4P, 5S. So now fill in your 5D with GM after 20 lines. And 6D. So we have 6S like you said here. We have 6D. So now.
Are these all single? Oh wait, no, there's 2.
Yes. A's good, G's good, MO's good, chlorine's good. Yes, yes. Yes, no. This one. You got the same problem, so it's got, this is not right, I'm just causing that to be wrong. After 6D, you should have 6P, you should have 3 lines. You should have. Like that. That's why that one's wrong. All right. Can we draw some dots? Yes, ma'am.
So I have a question.
Yeah.
You said that we couldn't have.
Yeah.
Like,
Yes. Yeah, but it won't matter because the number's a 4. So you pick the 6s, which is bigger than that 4. So your biggest number is always going to be bigger than an F. Okay? So the F is irrelevant. You're never going by letter, you're always going by number. And the number that is the outer shell is always going to be bigger than whatever number is on the outer. Okay? That's not easy. Oh, why? You have a break in your life night? Okay, so what is your outer shell? Okay, on top. This is 2 dots. This is 2, that's 2. How many dots? Got 2 dots. Yeah. 2 close. Close. 1.
And she graded hours, but she was,
Right.
she was, frustrated.
Alright, so give one of these to everybody while at the end. Now remember, your dots do not have to be in the exact same place that mine are. The pattern has to be the same. Okay, so like in this first one, everybody's got to have 3 pairs of 2 and a single. Everybody has to have a pair. Everybody has to have a pair and 2 singles and a pair. Does that make sense? Okay. So for PO, we need 2 pairs and a single. 2 singles. Okay. And those are the answers to the ones I put on the board. If you didn't do them all, those are the ones you did, check. See if you got them right. All right, questions? Need me to do any of them? No. Yes, no? So we feel okay about the first 6 questions on the quiz. So everybody can draw orbital notations?
Oh, yeah. I thought you meant those was gonna be the 6.
No, everybody could draw electron configurations and everybody could draw dot diagrams. Because I've already told you what the questions are. 2 orbitals, 2 electron configurations, 2 dot diagrams. With the exception of Xavier, who doesn't know how to do any of them.
So we're gonna do the second one.
Huh?
So for the dot diagram.
Yeah, I'm going to give you 2 elements on the periodic table.
Are you gonna give us a sheet that has,
I'm going to give you a periodic table.
Okay.
And I'm just going to pick 2.
no, I'm saying, are you gonna give us a practice sheet that has all the stuff on it? So we can,
I'm just going to put them on the board. Yes.
oh,
Okay. Yes, Lee. Talk louder than the fish tank. The highest number in the configuration. So which one are you asking me about? Give me an example of the one you're trying to do. So when you're looking at this one, okay, you're looking at 1, 2, 2, 3, 3, 4, 3, 4, 5, 4, 5,
did you,
6, 4,
did
5,
you do all your
6. Which number is
Okay,
bigger?
ask a question.
So those are the 2 numbers you're going to solve. You're going to
Which one was
the 6,
it was like the columns of
the
pictures?
6.
You know what I'm
Then everything else is
saying?
integral.
Does
Does that make sense?
Did you put
Okay, so
anti
that's
or
what you're going to use to draw your
pro?
dots.
Okay, anti.
So yes,
But
what
it
you
was like,
did
the
right
first
there.
was like a pro,
That
and
would
then
be
the
your-
last two were like anti, so
That's
like
how we
low,
make it.
anti, outweigh.
That makes
pro.
sense?
So the really long one after that, I think that was anti too.
I only had 2
Yep.
under.
Just
pro,
draw the
right,
electrons for those
yeah.
things.
So, okay, I didn't
So
know.
if we
So
went back
I
to
was
like
thinking,
your
I was
homework.
like, she wouldn't do
So
that.
put back your
I
homework.
was like, oh, well,
So like last night for homework. If we,
and then the second, I didn't
Look
know
at
it was
my
supposed to
goals.
so.
what's the highest here?
I shared some.
All this stuff you
I
do.
did some of it, I just have 2 passages left.
Yep.
3 passages left.
Whatever.
So
No, I just have the last 2 passages.
The last 2 passages kind of pick up like.
It was- that one was not like-
First
this is
long
not-
passage.
this is no other
The
way.
disadvantages, the last 2
Okay, so
passages.
you would draw
kind of
dots that
connect.
just has 2 dots together because that's the only one. You can just draw those dots. Okay? That make sense? Okay. Anybody else have a question? Nobody else.
No.
I just had to fix Leah's little quirk, and I've got everybody else other than Xavier who we need to fix because he missed 2 days. Okay. Y'all better not hand me a bunch of papers that are jacked up. All right. Now, we're going to color in a second. But before we color, let's talk about what we're coloring. Now, half of y'all probably believe that I have the entire periodic table memorized. I do not. I know patterns on the periodic table. I'm getting old. In my old age, I struggle. So, I know patterns on the periodic table. I know where numbers are on the periodic table, and I know where certain things are. So all I have to do is look at it, and I can visualize where numbers are, where blocks are, and I know where certain things are so that I can check. For example, most of y'all think I had all those dot diagrams memorized. No. Okay? You can pick any element up there, and I can tell you how many dots it has and what its dot diagram looks like based on where it sits on the periodic table. I'm going to teach you those things next week, okay? So that you can find them without having to draw out all of those things. The problem is some of you won't remember all of that by exam time, so you need to be able to fall back on, I know how to draw a dot diagram using the orbital notation if I forget how to read the periodic table. You have to have more than one skill, okay? Because some of you will have forgotten by June the 5th, 6th, whenever we take the test on how to find that using the periodic table. I know you all are going to tell me you can remember, Miss Wall. I don't need that. Yes, you do. Okay? So, how are we going to use this trusty periodic table? In a moment, I'm going to have you get 4 colored pencils. Okay? The periodic table is divided into 4 blocks, just like 4 sublevels. Now, I want you to color neatly. Not a museum piece. We're not spending a half hour coloring the periodic table. Helium needs to be the same color as these 2 columns. They do not have to be the same 4 colors that I pick. This is the S block. Doesn't even have to be written that close together because we're going to come back and put numbers in it in a minute. The P block is over here. Okay? This will be the P block. This right here will be the D block. And the final sublevel is what? F. So F will be down here. Okay? Now, it is 11:07. We need to be done with this in about 12 to 13 minutes tops. So, yes, really. There are colored pencils organized by color. There are also colored pencils in baskets and other things over there. If you are impatient and don't want to wait here, you need 4 colors. You may use the pencil sharpener because mine over there is designed to be able to deal with that. I'm wondering if it's the vet.
So you can pick up your child. Come pick up your baby. Oh, God.
Hello? Yes, ma'am. Okay. Thank you.
No problem.
I don't know why you thought to tell me the dog's ready. I told y'all I couldn't pick her up after school.
I know. I found purple and pink and good. Pretty as heck. Y'all are getting these out of order and it's gonna bother me.
Guys, just pick 4 colors.
They're messing up the colors though. They're putting them in different categories.
They need to stop doing that.
They're literally colorful.
She's got OCD on that. Y'all better.
Yeah, because I'm just going to fix it again in class.
Yeah.
I ain't gonna say that. I say everything just has to be.
I know a lot of people that have
That's the problem, anyone's on.
I can't cut on straight lines. But when you just have to cut stuff out in the kindergarten, I hate that. I absolutely hate it. I used to cut cricket.
I think for everyone. That's what I do. Me too. We were doing like dentist issues, and I was like, I got a crayon collector at home. She made me change my card.
I got it. I want to see the color too. And I got
Yeah, dude, I was like going back on stage and I changed my card.
Oh. Oh. So the very top one is part of the S block.
Yep. Oh my God. Dude, I was like, 9 years ago.
Let's not talk about it. Don't make me cry.
We're so smooth.
Shut up, someone. Just because I got a heart.
Yeah,
Why you so
man,
bitter?
you
You better.
I'm just.
That's crazy. You mean.
It's sensitive. It's just it's crazy that we're gonna be
Oh, it's
leaving.
not that.
Don't see it. Well, it won't be fun.
I'm ready to graduate, but I ain't ready for college.
What? Oh, yeah. You and me, Fabio. I think. There's more like me taking and you, Fabio.
They called you to change your thing. No. Okay, I'm gonna ask Miss Burton again. Okay, so mention my name.
Did you say freshman year?
I think I'm gonna go today, and I'm gonna ask her, can she sit in there with us? Yeah.
And then we just
I should have project potential.
Don't we have an induction ceremony?
Yeah, we did.
Cause I know we did back in what, 7th grade?
Yeah, like that was right. I don't think we've had one.
No, I've never seen it. I didn't even know they inducted people. I didn't know they. I thought you were.
I think it was more like a banquet. Like, I don't think it was induction. I think it was more like a big banquet too. Because they gave us our little plaque thing, remember?
Yeah, but I didn't know you could get in it like after middle school. I thought you got in it at middle school and it carries you through.
We don't have recess anymore.
I did too.
I don't want them to slow down.
Well, she said the only reason they started taking applications is because they thought they had enough people know about us. Yeah. Yeah.
Yeah, I didn't even know project potential existed until this year.
Yo, we could apply for it.
I did, because I remember when Jaden got in, I was like, why aren't you in it?
Yeah.
I was like, I've been in it for this long, and you still ain't know I was in it.
If you walk to her office, they're hanging out the door.
Okay.
Oh, yeah, you were guidances,
She went
yeah,
to
little office by the library, like.
Yeah, I know.
All right.
I still need to turn in my volunteer hours for this kindergarten. I don't have no volunteer. Is it 30 or 25?
No, it don't matter how many hours we have, you only need 25 when you're trying to get it.
Oh, when you're trying to get inducted, so it don't matter how much I have. Okay. Cause I was like, dang, I don't have 30 hours.
Just take it.
Only have 4.
Yeah.
I have to get like 6.
We graduate.
I have
I
15.
have to get 6 more by May 1st.
Hey, that's good for us.
Yeah, you know what I'm gonna do? I'm gonna probably just, I'm just gonna make 6 hours straight on Saturday.
Oh, you could do that.
I do have this.
That's hard for a long
And I'm trying to put Wednesday.
Dang, you don't pick up trash.
Right, so it wouldn't break your gear if I did this.
You know, Jaden, that when they have a big chance of getting in.
Has what?
There's a big chance of getting in.
I mean, yeah.
Joe told her the answer.
She made me mad yesterday.
That was funny. You got mad.
She interrupted me just to ask that useless question.
All right, I'm coming.
Has she hit on your girlfriend?
Really? Oh.
But they just hits on everybody. You shouldn't even take offense to it.
Not mine.
Literally everybody.
And she got a whole girlfriend.
Right. She's just flirtatious.
What was her girlfriend? That girl from Thomasville.
Is she taking her to prom?
And she moving down here. She's going to some club classes.
Why every girl she talks to, we want to move here?
Just knowing they're gonna break up.
Right. And they gonna move right back.
Ooh, that's next week.
Oh, you did.
I did.
I saw you get that.
I thought it was
That was kind of rude, though, yeah, sure.
I'm ready for our senior reunion.
Our class reunion,
Yeah.
our senior reunion.
I said senior reunion.
Oh, I thought you said senior reunion.
I did too.
I was like, what is that?
I think it was like,
I was gonna say, we didn't even graduate yet, have a reunion.
Hey, I'm off my face.
They just had a reunion.
The biggest is in September. He's so excited about it.
My mama's, I think it was 20th. Yeah, our 20th was during football season.
Yeah, because they all came up big old size and everything.
I get going.
This color was actually ugly when I got it on here. I'm upset.
Did you mess up the pretty picture, babe?
No, it's just that pink is really ugly. I thought it was
Yeah.
really pretty.
You need to be lighter.
It needed to be brighter. It looked like it's gray.
I'm gonna get you.
I'm gonna put the blue in the yellow. I'll put the red in the brown.
Is Easter always the first Sunday?
And I'll put the green.
When they figured that out, it was complicated. I went to tell one.
Cause I thought it was like the third Sunday, but it's all April first. Oh, he having a birthday party. I'm coming. I'm coming. I'm coming to his sleepover. I'm coming to his sleepover.
Date of Easter is after the first full moon occurring on or after the vernal equinox.
I didn't know it was that complicated.
Yeah.
But isn't something like the third Sunday of each year?
Yeah.
Is it? Oh, that's Thanksgiving. It's the third
Yeah.
Thursday.
Yeah, it's the fourth Thursday of November. Yeah, it's got to do with, it's a weird calendar day. It's based on the equinox and the moon and the rest of it. Like next year, Easter break is, the end of April. The prom is before Easter, I heard next year.
No.
That's what I heard. I mean, Easter break next year is like April 26th or something. It's really late. Easter's really late next year. It's the end of April.
That's weird. How are they doing that? Like it just jumps around the month. Like,
We have
what
a
holiday
holiday
is
next
year or is it next?
Sometimes Easter's in March.
That's what I'm saying. It's the only holiday that jumps around. Christmas stays within a vicinity. You know, Thanksgiving does too. Like Easter's just everywhere.
Easter could be everywhere. All right, is everybody done coloring?
Valentine's Day.
All right,
What?
with the exception
What
of
year we
Darlene,
have
apparently
Easter
he's
in, like,
still
December?
coloring. All right, if you have colored pencils, if you're done with them, go ahead and put them up. All right, because if you're still coloring like Jade is, finish. But if you're done coloring, you can go ahead and put them up because we will not get to any, I don't think, get to any more coloring today. The rest of it will fall on Monday. Now, we have to put the numbering in that goes with the coloring, okay? So, use a pen or a pencil and make sure it's dark enough that you can see the numbering. Now, before any of you say to me on quiz day, this fall, can I pull this periodic table out to use on the quiz? The answer is
No.
no. I will give you a nicer copy because this one is really ugly. A periodic table that you can write on. So you can label it all day long. You can put these numbers in, you can write SPDF all over it, okay? I will give you one that you can write on. But you cannot use the one that you're currently using. The one that you're currently using is your notes, okay? You're just taking notes on a handout or a graphic organizer, if you will, that I gave you. They're still notes. So, the numbers. You need to write in the numbers. All right. 1, 2, 3, 4, 5, 6, and 7. Okay, 1 through 7. Everybody with me so far?
Yes.
Okay. The D sublevel is 3, 4, 5, and 6. Notice where I wrote the numbers. I sort of straddle the lines between the S and the D sublevel. Okay? 3, 4, 5, 6. Okay? Now, over here, some people like to write a 1 here for this one lone S that's over here. A lot of times I don't write that one, but if you want to write the 1 that goes with the helium, you can. But the P has a 2, 3, 4, 5, and 6. Okay, 2, 3, 4, 5, and 6. And then the F has a 4 and a 5. All right, does everybody have those numbers in?
So the one up there is like in like that.
It's like for the helium, yes. Now, I don't recommend that you do the practice we're getting ready to do on your periodic table because the one we're going to color Monday will get very cluttered very fast, and some of you may want to add some stuff from Monday to this periodic table. And if you've already cluttered it up with examples, you have no place to write stuff. So I do your examples on separate paper if you're going to write them down. Okay? Now, let's say that we're going to read an electron configuration. Okay? Before you all say, no, I'd rather use the diagonal read it arrowed chart. Notice that a lot of times I did not give you anything down here in this bottom.
This bottom cannot be read using the diagonal arrowed chart, okay? Technically, some of the stuff that I gave you here can't be read with a diagonal arrowed chart. So we need to make sure that we know how to read this section using the periodic table. So let's talk about how to do that. Let's say that we want to write the configuration for silicon. All right, we read the periodic table exactly the way you would read the pages on a book. Everybody in here can read a book. So if we start reading the page on a book, where do we start? The left side, and where at? The top of the page. You read this the same way. What is the first number you see? What block is this? So you write 1S. How many elements do we have? 1. We write 1S2. Okay, 1, 2. When we get to the end of the row, where do we go?
Back to the left
Back to the left side. We drop down 1 row. What is the next number we see? What block do we have? How many elements do we have? 2. We write 2S2. When we get here, we just continue across the page. What is the next number we see? 2. What block is this? How many elements do we have? 2P6. Are we at silicon yet? Back to the left side. What is the next number we see?
3.
S?
2.
We're not at silicon yet, so we continue on. 3, P, and 1, and then you count silicon, which would be 3P2. Questions? You count silicon, so you would say 3P2. You count the element you're doing. Questions? Okay.
Why do you stop at silicon?
Because that's the one I said we were going to do.
Oh,
That was the example we were doing. Okay. All right, let's try another one. Because that was the example we were doing. All right, so pick a different one you'd like to do, somewhere in this upper half.
What upper half?
Somewhere along this upper half.
Iron.
Okay, we can do iron. So, where do we start?
1.
1.
S.
How many?
2.
Okay. Starting from here, we come back over here, and we have what? 1, 2. Okay, everybody with us on that so far? Okay, what's next?
2. 6. 3S2. 3E6. 4S2. 3D1.
Okay, 3D10 will take you across. Y'all said we were doing iron. 1, 2, 3, 4, 5. Count the iron. 6. Okay, 1, 2, 3, 4, 5. Iron is number 6. So you say 6. Okay, you with me? All right, do you think you can try it with your table?
Yeah.
All right. Let's pick something we haven't done, or see if I can remember something we haven't done. All right, we haven't done bromine. Let's do bromine and I don't know, something short we haven't done. Let's do magnesium first, because we haven't done magnesium, and then do bromine. All right, and then we're going to take a stab at how to read the bottom. We won't get very far, so the quiz will probably be Tuesday, which means it will probably be the first grade of the new quarter.
Oh.
Because I'm pretty sure that if I do it Tuesday, we're going to put it on the new quarter. Let me check Miss Glass though.
Let's do it on the chart like separate sheet.
I'd at least do it on the back. I'd probably do it on a separate sheet of paper though, because Tuesday or Monday's chart gets real cluttered. You'll see what I mean Monday. It's bad.
did it.
Now, this should make it easier for you to catch up on what you missed.
It's easy.
And you should be able to catch up on orbital notation faster.
What's the thing we did today with the arrows?
That's orbital notation.
What's the one?
The electron configuration is what you just learned how to do. You just didn't learn to do it the other way with the arrow chart.
All right.
What you're doing right now is the electron configuration we started with. Okay? You got to learn how to do yesterday to do the dot diagrams. But this is going to help you get there. All right, so if we do magnesium, what do we read first?
1S2,
1s2,
2S2,
2s2, 2p6, 3s2. All right, for bromine, 1s2, 2s2, 2p6, 3s2, 3p6,
4s2, 3p10, 4p5.
Yeah, 4p5. Yeah, it could go to 4p6, but since we're doing bromine, you should end on 4p5. Yes, sir. Well, shorthand, we're gonna get ready to start. Okay, which is why I said we won't have the quiz on Monday because we haven't got shorthand yet. We're getting ready to start that part. All right. So, how many of y'all are tired of starting in 1s2 all the time?
Oh, wait.
I know I am. Okay. What?
So we got like 7. You gotta come down here and dump the
Yes.
first.
Yes. Okay. So shorthand notation is where I want to sort of finish up for the day, and we won't be able to finish shorthand. We're just going to start it, and then we'll do this bottom half on Monday. Okay. But let's talk about some shorthand. All right. Shorthand notation also has another name. It's often referred to as noble gas configuration or notation. Because you have to use a noble gas. Now, some of you, like I've said before, had a better experience in middle school, and someone probably taught you where the noble gases were. Some of you haven't the foggiest notion. So on your periodic table, and we will label this on the one we're coloring on Monday, but these, in this very last column, are the noble gases. Okay, the very last column are the noble gases. So when we go to use shorthand, we have to use an element out of the noble gases. So it sounds really hard, but it's not. You choose a noble gas, and you write it in brackets, and then you write the remaining electron configuration. Now, how do you know which noble gas to pick? You pick the one immediately before your element. Now, we only have a choice of 6 of them. So it's not like there's a bunch of noble gases to pick from. Okay? So we're just going to find the one closest to our element that's before it, and then we write the rest of the configuration after that element. You need me?
No.
Oh, okay. Just watching.
Just watch.
Okay. All right, we caught up?
Yeah, sure.
Yes or no?
Yes.
Okay. So if we cruise back to where we were. All right. So the noble gases, different color, are here. So here are my noble gases. So I have to pick either helium, neon, argon, krypton, xenon, or radon. Okay. So let's say that we do, what do we do in indigo? Bromine?
Yeah.
All right. So you had that long configuration we just wrote down a second ago, right? So what is the noble gas immediately before bromine? Any ideas?
AR.
All right. Yeah. If you don't know, go to the end and go up 1. So what's the noble gas before bromine?
R.
Argon. All right, so we're going to write argon in brackets. Now, that takes care of everything up to that. You don't have to write this down. Everything that you already wrote, that is covered in writing AR in brackets. That took care of all of that. Now, we're writing everything after that. So what comes after the argon? So you write 4s2, 3d10, or p5. That's shorthand. Okay? Does that make sense?
Yes.
Okay? So if we pick a different one, just to try, okay? So let's say that we do vanadium here, and we want to write it in shorthand. Okay? What's the noble gas before the vanadium? All the way to the end, and up one is argon. All right, what comes after it? 4s2. 3d, how many?
3.
And that's shorthand. That makes sense?
Yeah, makes life easier.
Okay. Homework. All right, orbital notation.
You're making a week.
Let's draw. I don't know. Let's do nickel. Electron configuration. Let's draw scandium for a dot diagram. Let's do potassium and arsenic. Now let's not do arsenic. We've done that one. Let's do oxygen. Let's do a short one. And for shorthand, let's do, I don't know. Let's do SB and we've done so many of these things in GA.
We do K and O.
K and O. Here, I need a picture too for the website because I will not remember what on earth I assigned later when I try to put this on the website. All right, does everybody have it? Where I take this down. Remember, if you're one of the folks who has missing assignments, when are the last 2 days to do makeup work? Monday and Tuesday. That's only for recent stuff. All grades have to be in the computer before we leave for break. I only have Monday and Tuesday. So if you want to make anything up, get your butts in here. If you still have colored pencils, get them in my box, please.